Hello, in this video we're going to start looking into what's inside an atom. So here you can see two different illustrations of an atom, basically to show you the same thing. Okay, for any atom, you can see look like there's a superstar in the center, okay, in the core part, okay, and there are some kind of orbits around the super core, and there's some tiny particles traveling on the orbits. So you can see this is a two-dimensional illustration. This looks like a three-dimensional illustration here. Okay. So what we're trying to find out here is what does the atom look like? What is the atomic structure? Not just for any just this atom, any elements. Okay. Uh, so let's look into this core. Okay. So this core, the name is pretty famous. It's called the nucleus. Now you can see nucleus is not just one particle. Nucleus is actually composed by two different particles. You can see the orange ones and the yellow ones with a plus symbol on it. Okay, let me use green ones representing, or the orange one. Let's say green ones representing the orange particle here, which has no symbol on it, is the neutron. Okay, now I'm using the red representing the yellow particles with the plus symbol. They are proton. Okay, so number of neutrons, number of protons makes up the nucleus, and then there are some even smaller ones. Okay, you can see if you take a closer look, you can see there's some negative symbol on it. Okay, so they are actually electrons. Okay, so basically, atomic structure, any atoms, okay, is composed by these three kind of particles. Okay, we call them these three kind of particles. We call them subatomic particles. Representing sub means they're smaller than the atoms. Okay, now with these three kind of particles, okay, how do we describe atomic structure in any atoms? Well, other than neutrons and the protons makes up the nucleus, which is like the super core, okay, very strong core in the center, and the electrons are outside. But electrons are not random everywhere, okay. It seems like there's a certain pattern they're traveling on some kind of orbits. Okay, we'll get into that later. Now we want to get into more detail about these three things from several aspects. Okay, let's put it this way. How about mass? I'm running out of space here. Let me. So what? How much do they weigh? How big are they? Do they carry any charge? First of all, we're talking about all these particles, including the atoms, okay, and subatomic particles. They're super tiny. First of all, okay, compared to anything we would be able to see in our daily life, they're super tiny. So if you're trying to describe this kind of things using kilograms or pounds, the number will be extremely small. Okay, so that's not what we're trying to do. We're just trying to want to see relatively, okay, at the micro scale, how big or how heavy these things are. Okay, so let's say mass-wise, okay, the neutron and the proton, which both are in the nucleus, okay, we unify them into a number 1. Okay, and then we'll give the units here is AMU. Now AMU stands for atomic mass unit. Okay, so we take the first letter AMU here, which is obviously a very small unit, okay, in terms of weight. So, but a neutron weighs exactly 1 AMU. So relative to neutron, proton weighs how many? Proton weighs exactly the same. Okay, so you can see proton and neutron are about the same weight, mass, okay. Electrons weighs about roughly, okay, 10 to negative 5 MMU. So what does that mean is, even at the micro scale, compared to relative to neutron and proton, the electron weighs almost nothing. So the weight contribution to the atom from electrons are completely negligible. Okay, so that's why also in the picture you can see they're relatively smaller being drawn compared to protons and neutrons in the nucleus. Size-wise, it's the same. Okay, size-wise, compared to the entire atom. Okay, let's say this is the atom. Okay, this is where the nucleus is. Okay, so this is where the nucleus is. The size of the atom, it can be represented by this radius. Okay, so relative to the size of the atom, okay, all of these particles are almost nothing. So I'm not saying they are zero volume, okay, they're just too tiny to be counted, okay, compared to the radius of the atom. The atom has certain volume, okay, but the particles in there are super, super tiny. So that's basically what you can imagine. Even though there's a very, very heavy core here, which contributes the mass, you can see it here, electrons contributes nothing to the weight of the atom. Pretty much 100% of the weight are on the nucleus. Okay, but size-wise, okay, even the nucleus compared to the size of the atom, it's almost like nothing. Okay, charge-wise is kind of interesting. Okay, neutron is given the name neutron is because it doesn't carry any charge, so it's neutral. By the name, you can tell that. Proton carries some kind of charge. Electron carries, again, there's one here, it has some super tiny unit, okay? It's not 1 coulomb or anything like that. Electron, each one electron carries the same amount of charge as the proton with opposite symbol. So we define proton symbol of charge is positive. So the electron has the opposite symbol, which is negative. So you can imagine for a neutral atom, that means the overall charge is 0 when you have equal number of protons, electrons. Okay, so this is the numerical relative numerical relationship between them. So let's look at any specific atom, which is nitrogen. So we take, remember we have been shown that the periodic table, let's take one of the elements or one block from that periodic table out, and this is what probably look like. By the way, different periodic table may have different layout of inside of each block, has different layout of information, but should give you several key information should be the same. Okay. Usually there's a symbol, atomic symbol, which is the biggest, very big letter or 1 or 2 letters. Okay, so this is N, which stands for name, nitrogen. Okay, there's usually another big number here. Okay, either on the left up corner or usually it's right above the symbol in the center, upper part, and that's called atomic number. There's usually another number which is called atomic weight. So this is the total weight of this atom in the unit of AMU. Again, AMU stands for atomic mass unit. Okay, now the question is, how do I know the number of all these guys, or so-called subatomic particles, neutron, proton, and electrons? How do I know these guys? Okay, let's put it this way. There are several numbers we want to learn about any elements. Okay, and then we have to be able to distinguish what they are. For instance, if you are given any elements, you have to know the symbol, you have to know the name, you have to know the, of course, number of proton, number of neutron, number of electron. Also, the periodic table will give you, like we've said, atomic number of atomic weight. So atomic number and atomic weight. All right, so how do I find all of these things? It seems like let's say nitrogen from the example on the slides. Okay, you have N, symbol is N, name is nitrogen. All right, you're given a couple of numbers. Okay, atomic number is 7. Atomic weight or atomic mass, sometimes it's called atomic weight or atomic mass, is 14.013. Let's do a simple rounding. Okay, 14. Now there are a few simple relationship you have to memorize. Okay, which is also very useful. That is atomic number is always the same as number of proton. So basically we're using all of these elements as proton, neutron, electrons. Okay, they all have different number of each one of them. We're using the number of protons to be the identity of the elements. Okay, so number of protons is always the same as the atomic number. So immediately you can fill out, okay, by looking at atomic number 7, you should know number of proton is going to be 7. And also, like we said, because you are trying to get the net charge to be 0 in the neutral atom, which also means number of proton, which is a positive charge, equals to number of electron, which is a negative charge. Okay, so that means if you have 7 protons, that means you have 7 positive charge in the nucleus. In order to neutralize 7 positive charge, you need 7 electrons to have 7 negative charge. So the number of electrons is always going to be 7. Okay. Now one more. We already said that the electron contribute nothing, which is almost nothing, okay, to the atomic weight. Atomic weight is atomic mass. By the way, this 14 is in the unit of AMU again, okay. So 14 AMU, they are all coming from the number of protons and number of neutrons. Keep in mind that each one proton weighs 1 AMU, 1 neutron weighs 1 AMU. So if your total weight is 14 AMU and you have 7 protons, that means number of neutron equals to atomic weight minus number of protons. So number of proton and neutron adds up to the atomic weight, which is usually in this case, the number of protons and number of neutrons happen to be 14 minus 7 equals to 7, the same, but not necessarily always true. Okay, so this is how we find out all 3 different subatomic numbers from the information from the periodic table. Okay, let's see if we can do another exercise just like that. Okay, usually I'm going to give you a part of the information about elements, asking you to fill out the rest of them. Okay, let's say we have an element that's called phosphorus, which has a symbol P, name phosphorus. Okay, now this element has 15 electrons and 16 neutrons. Can you fill out number of proton, atomic number, and atomic weight? But not by looking at up on the periodic table. Okay, so you can pause the video here, see if you can figure it out using the relationship here. Okay, so the first number you can fill out right away by looking at 15 electron is you must have 15 protons. By the way, the condition here is we are talking about neutral, overall charge 0 element. Okay, sometimes the atom does not have to be neutral. Okay, then that's going to be a different story. All right, so now you have 15 protons because you have 15 electrons, and also because you have 15 neutrons. That means you're gonna have 15 plus 16 equals 31 AMU atomic weight. And then what about atomic number? Well, atomic number needs to be exactly the same as number of proton, no exception. Okay, no exception. Is atomic number always going to be the same as number of electrons? When it's a neutral atom, yes. Okay, again, the condition for the number of proton and number of electron to be the same is that we want to have a neutral atom. If it's not neutral atom, which could possibly be true, then the number of electrons and protons are not going to be the same. Okay. All right, so this kind of practice you can always do using a periodic table by yourself. Okay.